जी सर, here we go. अच्छा जी, which list contains only SI base units? You can see my screen. I
D.
think I've shared the screen. G.
D.
D. It would be second Kelvin kilogram. Excellent. Question number 2. Any idea how we would solve question number 2?
No.
Sir, what we'll have to do is we'll have to find the SI units for the quantities which are mentioned on the right hand side, and SI units for the quantities which are mentioned on the left hand side, and then we'll have to equate the two. Okay, so if you could find, yeah, children, let's do it together. What would be the SI unit for tension? Tension is a force. Yes, sir.
Yes.
So the SI unit of force would apply. So force में क्या होता है? Mass times acceleration. So this would become, mass is kg, would become kg meter per second squared. Fine. Then I've got length. Length is measured in
Meters.
meters. I'll write meter. Then I've got mass. Mass is measured in kg. So I've got kg
kg.
over here. On the right hand side, I've got meters per second. Yeah, ms minus 1. अच्छा जी, on the left hand side, I've got a power which I don't know what it is. kg cancels kg, and then I have got meter squared per second squared. Did I miss something? kg meter per second squared. ठीक है, divided by kg. So it would be meter to the power 2 and s to the power minus 2. ठीक है। नहीं, ये सिंगल पावर तो नहीं आ रही, सिंगल पावर तो नहीं आ रही, लेकिन एटलीस्ट मीटर पर सेकंड, हाँ ठीक है ना, मीटर पर सेकंड। सो आई नीड पावर 1/2 ऑन द राइट हैंड साइड। तो ये मेरी जो वैल्यूज हैं, इनकी भी जो पावर है, इफ पावर ऑन टॉप ऑफ पावर, दिस वुड बिकम मीटर पर सेकंड। यस सर।
Yes.
तो दिस n शुड बी 1/2। अंडरस्टूड हाउ इट सॉल्व?
Hmm.
ठीक है जी। क्वेश्चन नंबर 3 इफ यू कुड डू राइट नाउ। क्वेश्चन नंबर 3 में जो हमारा कॉन्सेप्ट यूज हो रहा है कि वी हैव गॉट मोमेंटम। ठीक है, मोमेंटम क्या होता है? मास टाइम्स वेलोसिटी। देन सर दिस मोमेंटम इट कैन चेंज एज वेल, सो चेंज इन मोमेंटम इज गिवन बाय एम वी माइनस एम यू. There is a later momentum, there is an initial momentum, so the difference between the two is the change in momentum. Fine. ठीक है, अब मैं अगर ये कहूँ कि आई वॉन्ट टू कैलकुलेट रेट ऑफ चेंज इन मोमेंटम, सो आई से डेल्टा पी बाई टी इज इक्वल टू एम वी माइनस एम यू बाई टी। ठीक है, तो राइट हैंड साइड कैन बी फर्दर सॉल्व एम टाइम्स वी माइनस यू, and I can write t over here, so this is m a. So this rate of change in momentum is force. Okay, the rate of change in momentum is force. This is the first thing that we have to remember. The other thing that we have to remember is change in momentum can be calculated as force into time. Change in momentum, sir, we mentioned it was it is called impulse. यहाँ भी हमने इसकी ये equation लिखी है, so we can also say mv minus mu is equal to f into t, and they're both equal to impulse. So if ever you're given impulse or you have to calculate impulse or you have to use impulse, you can use the formula either mv minus mu or you can use the formula force multiplied by time.
Okay.
चलें. With this information, if you could please solve question number 3. जी sir, did you get the answer?
Yes, 6,414 newtons.
Excellent. And did you have a part B as well in this?
Sir, 644 kilograms.
644 kilograms, you say? Sir, fine if you're doing with the value of 10, but we wouldn't be using value of 10, we would be using value 9.81. ठीक है, तो
Okay.
9.81 से कितना आंसर आएगा?
656.
656.
Yeah.
ठीक है. अच्छा सर, वन मोर थिंग बिफोर वी मूव टू दिस क्वेश्चन नंबर 4. सर फोर्सेस के बारे में वी नो अ थिंग्स के एट ए बॉडी मल्टीपल फोर्सेस कैन बी एक्टिंग एट अ टाइम. ठीक है, तो इफ आई हैव गॉट ए फ्री फॉलिंग बॉडी, so I know it is just the weight of the body which is pulling it down. लेकिन if there is the same weight, if it's lying there on the earth, so weight would exert a downward force, and the earth's Newton's third law, it tells us that this earth would also exert an upward force. ठीक है सर, this force is called contact force. कॉन्टैक्ट फोर्स. अच्छा, दूसरी बात सर, न्यूटन का जो सेकंड लॉ है उसके बारे में वी हैव टॉक्ड मेनी टाइम्स कि इफ देयर इज एक्सेलरेशन इन ए बॉडी, if there is acceleration in a body, that acceleration would always mean that there is a net force which is acting on the body. ठीक है, तो if in this case, the first case, this weight it is just lying motionless on the ground, so that would tell me कि जो net forces हैं they are zero. The upward force is equal to downward force. ये बात clear है सर?
Hmm.
ठीक है. If there were any, so for example, I am sitting on my seat. I am exerting a downward weight on the seat, but I am not accelerating. So that tells me that the seat is also exerting an equal amount of force up on my body. So that would mean the net forces they are zero. So the body is not accelerating. Also, sir, we have to remember that if we ever say that acceleration is zero, that does not mean acceleration is zero. This does not automatically imply that velocity is also zero. A moving body can also have zero acceleration. ये बात तो hopefully आपको clear है, इसमें कोई मसला नहीं है. So anybody which is moving at a velocity of, sir, let's say 2 meters per second. So v is equal to 2 meter per second. It can also have acceleration zero. And if acceleration is zero, we know that this body, it has got zero net force acting on it. Even though the body is moving, the net force on the body is
Yeah.
zero. ये चीज़ clear है हमें?
Yes.
ठीक है. अच्छा सर, एक और बात है कि द फोर्सेस विच आर एक्टिंग ऑन द बॉडी, जो इस पे है, लेट्स से ऑन अ हॉरिजॉन्टल सरफेस, इट्स इजी टू इमेजिन. ये चलें एक और बात कर लेते हैं बिफोर वी गेट टू दैट एंगुलर थिंग. अच्छा सर, जो दूसरी बात हमने ये करनी है कि इफ ए बॉडी, लेट्स से कि दिस इज ए कार एंड द कार इज मूविंग फॉरवर्ड एंड नाउ वी हैव गॉट एयर रेजिस्टेंस एज वेल. ठीक है, तो if this car is moving forward, there are two possibilities: either acceleration is zero or the other possibility is that acceleration has a certain positive or negative value. So if acceleration has a positive or negative value, we know that the forward force by the car is either more than air resistance or less than air resistance, because that would result in acceleration. उसकी वजह से net force. If the forward force and the air resistance they balance each other, तो net force zero होगी और acceleration zero होगी. This thing understood?
Yes.
So similarly, if I've got a falling body, free fall कर रही है कोई body, and again there is air resistance, so I know this gives rise to the concept of terminal velocity. Right, sir? Do you remember what
Yes.
is terminal velocity and
Yes.
where it comes from? If you could please repeat the concept for me.
Terminal velocity is when the forces get balanced.
Excellent. So for a falling body, initially what would happen is that acceleration would have a value of 9.81. But as the body accelerates, that means that the body gains velocity. And as it gains
Right.
velocity, that would mean that air resistance also increases, right?
Yes.
So air resistance increases. Air resistance is the force. So this force, it would act as counter to the downward weight which is acting. But the body, so initially when it counters the downward force, it does not immediately nullify it, right? So as the body keeps gaining velocity, the air resistance keeps increasing until weight is equal to air resistance. Weight is equal to air resistance. So now the two forces are balanced. So net force is zero, which would mean that acceleration is zero. Hence, the body at this point it would stop accelerating any further, and whatever speed it has attained by that point, that would be the speed which we call terminal velocity, and with that speed it would move downwards. Understood, sir? No confusion in
Hmm.
this? Okay. The same could happen for a body. So this was a body falling through the air. But what if I've got a giant body in which there is a liquid, okay, and this body has a weight, and I lower this body into the liquid. The liquid, the force or the resistive force which the liquid exerts or a fluid exerts against the body falling in it, this is called upthrust. ठीक है. And this upthrust, the same way for a falling body, as the velocity increased, air resistance increased. For a body falling in liquid, as it goes down, as its velocity increases within the liquid, the upthrust would also increase until we get to the point where weight is equal to upthrust. Weight is equal to upthrust. So at that point, net force would be zero, which would mean acceleration is zero, and the body would attain the terminal velocity at this point. Understood? So this terminal velocity, it can not only be achieved for a body falling through the air, it can also be achieved for body falling through liquids. And instead of air resistance, obviously this is liquid, so the force that we have, the counter force that we have, that would be upthrust. This also understood, sir?
Yes.
ठीक है. The next thing that we have to look at is perhaps something new or a new way of looking at things that we already know. Let me draw a plane for that. ठीक है. So this is a horizontal surface that we have got, and on top of it there is this inclined plane. One. ठीक है. अच्छा. Now this inclined plane, it is at an angle theta to the ground. Yes, sir. Acha. And on this inclined plane, I've got a box of weight W lying on it. Mm, yeah. So, sir, here I have got my box W. Yes, sir. Acha. Sir, I know that if this box was to slide down this plane, there would be the force of friction which would oppose its slide down the plane. Yes, sir.
Hmm.
Acha. Also, another force which is acting right now, that would be weight of the box. So let's see how the weight of the box would act. Okay, weight of the box would act in this direction. The normal contact force, this would be perpendicular to the surface on which the box is lying down. So the contact force would be in this direction, opposite it second. It would be in this direction. Yes. So let me erase this. Ji sir, so far so good. Okay, we have just mapped out all the forces which are acting on this body. So the next thing that we will do is कि we will try to come up with a calculation to calculate these as well. आप अगर इतनी diagram draw कर लें, then we will talk next कि क्या है.
Yes.
ठीक है. Sir, now I know this seems to be a right angle triangle. So this force which is acting over, yeah, this angle which is being made between the weight and the inclined plane, this angle would be 90 minus theta. Do you agree, sir?
Yes.
ठीक है. तो this 90 minus theta, it would have two components. इसके components कौन से होंगे? Let me draw those. सर एक इसका होगा vertical component which would be perpendicular to the surface, and one would be the horizontal component which would be along the inclined plane. इस चीज में कोई confusion?
No.
ठीक है. तो if this angle is 90 minus theta is the angle, so I am now rotating the diagram. I am just copying the same diagram to give you an explanation of how we are getting about the components. So the same diagram chosen, you don't have to redraw it. This is just for the sake of simplicity कि आपको समझने में आसानी हो जाए. You have got your notebook. All you'll have to do is you have to rotate your notebook. तो ये जो आपके पास inclined plane था, this looks like the horizontal, the x-axis. Yes, sir. अपनी वो notebook को if you could rotate, so you would see कि this inclined plane is along the
Hmm.
x-axis. Got it, sir? अच्छा.
Yes.
So now I have got two components of this inclined plane. एक along x-axis. अच्छा. And the force that we are talking about here, this is weight of the object. Yes, sir. This is weight of the object. तो weight का जो x component बनेगा, that would be that should be w cos theta, and the theta that we have over here is 90 minus theta. The angle that it is making with the supposed x-axis is 90 minus theta. Yes, sir. So it would be w cos 90 minus theta, और जो इसका vertical component होगा, that would be w sin theta. So theta over here is 90 minus theta. So this would be w sin 90 minus theta. Yes, sir.
Yes.
ठीक है, इतना नोट कर लें, then I'll talk about the next thing. Noted, sir?
Hmm.
ठीक है. Sir, the next thing that we have to know is cos 90 minus theta is sin theta. ठीक है. तो if I say, जल्दी से इसकी एक एग्जांपल देख लेते हैं. If theta is 60. ठीक है. तो 90 minus theta would be 30. Yes, sir? 90 minus theta would be 30. अच्छा, अब जल्दी से अपने कैलकुलेटर पे करें cos 30 and sin 60. They would both give you the same value. तो cos किया 90 minus theta और sin किया theta. They would give you the same value. Cos 30 and sin 60. ये हमारा उसको ट्रिग्नोमेट्री का सिंपल सा एक रूल है. यस सर.
Hmm.
ठीक है. सिमिलरली आपके पास साइन 90 माइनस थीटा इज इक्वल टू कॉस थीटा. ठीक है सर. तो इसकी हमारे यहाँ इस केस में एप्लीकेशन क्या आएगी कि जो हॉरिजॉन्टल फोर्स थी विच वाज कॉस 90 माइनस थीटा, आई कैन नाउ से दिस इज इक्वल टू डब्ल्यू साइन थीटा. और जो वर्टिकल कंपोनेंट था इसका विच आई सेड डब्ल्यू साइन माइनस थीटा, आई कैन से दिस इज डब्ल्यू कॉस थीटा. गॉट इट सर?
Yes.
ठीक है. अच्छा सर, गोइंग बैक टू द ओरिजिनल डायग्राम, नाउ आई नो कि ये जो फ्रिक्शन के अगेंस्ट कंपोनेंट था दिस वन और द वन डाउन द स्लोप, दैट आई हैव फाउंड आउट कि दिस इज डब्ल्यू साइन थीटा. तो आई गो टू द ओरिजिनल डायग्राम and write over here कि this force which is acting against friction, this is W sin theta. Right? And this force which is acting against the weight or normal contact force, so this was contact force over here, contact force. Yes sir. This component is W cos theta. Let me know when you have noted this down and if you understand this thing. If you want me, this is a bit tricky. So if you want me to re-explain this, I can do that, but you'll have to confirm for that okay, you want a re-explanation for this. Or if you have understood, that's also fine. You can tell me okay, I have understood. In both cases, I will need a confirmation from you.
Done. Copy.
Achha ji, so if we write conclusion of what we have written everything, if a weight W is lying on an inclined plane making angle theta with the horizontal, then component of weight down the slope, component of weight down the slope हमारे पास कितना आया है, that is W sin theta. or we can also say mg sine theta. Yes, sir. And component of weight against the surface, yeah, perpendicular to the surface, perpendicular to the surface is equal to w cos theta or mg cos theta. Understood, sir?
Yes.
ठीक है. अच्छा, now what we would, as we can see from the diagram, कि ये जो mg sin theta है, this is what would act against friction, act against friction. So if an object is sliding down the surface with a constant velocity, ठीक है, object is sliding down the surface with a constant velocity, I would know कि जो horizontal surface, sorry, जो slope के surface पे the forces they are balanced. That is why it is not accelerating. There is constant velocity. ठीक है sir. So that would mean friction is equal to mg sin theta. Friction is equal to mg sin theta, because otherwise the object, it would have accelerated if there were no friction. So the object would have accelerated. If it is moving down the slope with constant velocity, it means forces on the slope, they are balanced, and that would mean the component of weight down the slope is equal to friction. ठीक है sir. Similarly, we know that this object is not accelerating uh, perpendicular to the surface that it is lying on. So this white and pink line, this w cos theta and this white line, it is not accelerating upwards or downwards in this direction. So that would mean that the forces along this y-axis, if I consider it, they are balanced. Yes, sir. So if they are balanced,
Hmm.
so that would mean that weight is pushing it down, and there is this normal contact force which is pushing it back, and they have balanced each other out. That is why it is not accelerating along the line of the cursor that I have and that I am moving. ठीक है. तो that would mean कि normal contact, ये जो हमारा mg cos theta आया है, this gives us the normal contact force. Got it, sir?
Hmm.
ठीक है. So again, for an inclined plane, I'll just give a quick review कि there was an inclined plane making an angle theta with the horizontal. So I drew down the weight, and I could see that it's making in the right angle triangle, it was making 90 minus theta. ठीक है. तो now if I rotate the diagram and I say that this weight is acting at an angle 90 minus theta and the inclined plane is the horizontal, so the case would be कि it would have an x component and it would have a y component. जो इसका along the inclined plane component होगा x component, that would be w cos theta, but theta over here is 90 minus theta, so it would be w cos 90 minus theta, and cos 90 minus theta would be sin theta. Similarly, the perpendicular component of it would be w sine angle, and the angle is 90 minus theta, so w sine 90 minus angle, or w sine 90 minus theta, and that would be w cos theta. So the conclusion is the component of weight down the slope is w sine theta, and the component of weight perpendicular to this slope is w cos theta. So down the slope it is acting against friction, and up the slope, or sorry, perpendicular to this slope, it is acting as the normal contact force. Understood, sir?
Sir, could you
Sorry,
explain?
G. Can I explain what?
Explain it again.
The whole diagram, everything?
No, no, just right now what you said.
जी, I was saying कि this weight, finally the conclusion is कि this weight which is lying over here, it is doing two things. One component of it is making it slide down the surface, and that is equal to W sine theta, because we have just found out through the other diagram. Okay, this down the slope, it would be W sine theta, because in this diagram we made inclined plane as the horizontal. So this W sine theta that we found out, it was this over here. Let me draw an arrow. ये हमने find किया, and this vertical component that we found out, it is this one. ठीक है, so it is doing two things. One, it is acting against friction. The component would be W sine theta or mg sine theta. The other thing it is doing is it is acting, the weight is acting on the surface, and the surface provides back a contact force. Since it's not accelerating up or down in this plane, so it would be W cos theta. This component of weight W cos theta, this is equal to the contact force which is being experienced by this object.
Yes.
ठीक है सर. Acha, with all this information available now, I don't know if it would be immediately used in the next question or not, but this is something that you have to understand for some questions which would show up in this chapter. Acha, 1 second. The next question that you have to do was question number 4, please. ठीक है जी.
Sir, 112 newtons.
12 newtons, you say 112 newton. Fine, sir. For the first one,
388 newtons.
388 newton. ठीक है, the resultant force would be 388 newton, and the acceleration would be
5.5.
5.5. ठीक है. If I give a quick solution of this thing, so what needs to be done is, so first of all, we have to calculate weight. So weight would be mass times acceleration. So W is equal to 70 times 1.6. ठीक है. For the second part, we have to calculate the resultant force. So the resultant force, net force, will be equal to the upward force, the upward pull with which we are making it go up, minus weight. So the upward pull is how much? It mentions 500. So 500 minus the weight is 70 times 1.6. Okay. And lastly, the acceleration. So I know net force is equal to ma. So net force, I just calculated 500 minus 70 times 1.6. This is net force is equal to mass is 70 multiplied by A. So I solve this one for A, and I get the value of net force. Excellent. ठीक है. Do we have time for more questions, or do you have to leave to get ready?
I have to go.
You have to go. चलें. We keep it till here. Inshallah, next class we move forward and discuss further questions. So any question or any confusion still from what we have learned, or you understood everything?
No, no, no.
चल ठीक है. See you in the next class, inshallah. Assalamu alaikum.
Walaikum salam.